Thank you, thank you. Yeah, it's really glad to be here. So I'm Matt. I'm the co-founder and CTO of PingCap. And the speaking of PingCap, maybe our project name is more well known. PingCap is the company behind the open source database HiDB, which is the distributed cloud-native database. I would say we are quite successful in the traditional data platform world. But this year, I think it's a great timing to put more investment in the AI community, because we think that's going to be changing everything. So I'm an engineer. I still coding every day. So yeah, that's pretty myself. So speaking of the right way, I think today we don't have the common sense about which is the correct way. So I think the right way here is more from my own experience. So maybe in the near future there will be some better ways. Yeah, who knows? Okay, so today is I think the most important things are happening, which is the agent. Everyone is talking about agent, but think about 2 years ago. At the very beginning, we just have the LLM. We don't have, the problem of LLM is, to me, it's just more like an interactive Wikipedia. It's just like a big compression of the whole internet. It cannot answer the question with your own context. There's a big problem. And then people invented RAG. So to answering the question more relative and in a more relative way. But to me, the RAG is still the more a very technical term to me. I try to explain what is RAG to my mother. She knows nothing about the technology. She couldn't understand what is RAG. But when I introduced the agent, she immediately understands, oh, that's something I actually want. So, just like I said, today we don't even have a clear definition of what is AI agent. But in my own understanding or on my definition, the agent is more focusing on finishing the task and also with the memory. But the RAG is more like searching and answering the question based on the static, the knowledge base or something like that. So this is the agent. I think today our open source LLM or the first tier, the LLM provider is good enough to build actually something useful. So what is something useful? Just like I said, not like early days, the LLM can only answering the just act like an interactive Wikipedia. Today, agent will, we can build some, state. It is just not a stateless chatbot anymore. So that means the data is becoming more and more important nowadays because I'm the database engineer. I found that in today's AI community, database is one of the most important infrastructure, but in the database community, we don't have too much love. But I think in the near future, that will be very, very important. This is a very interesting meme I always want to demonstrate to my audience to demonstrate how important the data is. Okay. Well, before jumping to the details, I want to show a quick. It's a demo. It's my homemade agent it is a Salesforce agent. As a company's founder, I always want to put attention in the sales team. In my company, we use Salesforce a lot, but as an engineer, I don't like Salesforce. I don't want to spend time on Salesforce, but it is super important. So I try to build my own agent to access my to help me to get the sales insight from my Salesforce data. So because the font is too small. I will repeat the. I asked the question about, hey, give me my top 10 most hardworking sales, and the AI will generate actually the the ranking of the sales in my company. I can ask another different question. For example, like give me the overview of some random sales guy, and the AI will generate the overview of his or her work. So this is what we actually want. So today, if we want to build a useful AI agent, that's basically the overall architecture today. So in the left side, the LLM part, we will have the right context and sending the context with the prompt and to the LLM that will generate the action plan. The action plan will list to some tool use, and the most important part of the memory system is the update and the reflection. Every time you interact with the AI agent, that will trigger the memory reflection to update the memory. And the next time it will have in the next time you will have a better context for the next task. So that's basically the architecture looks like. So reviewing this architecture, you're saying, hey, this is quite similar to the RAG system. But today I think the memory is not equals to RAG. Just like I said, RAG is more like query a passive knowledge base. It is static. It is static data. And also, there is also the common mistake or misunderstanding, which is when we talk about RAG, a lot of engineers, saying, hey, maybe we should use a vector database for building a RAG. But like I said, let's back to this agent application. I don't even use the embedding or the vector database for building this tool, for building this agent. So, and for the next few slides, I will talk a little bit about what's wrong or what's the problem of RAG. For example, this is the typical RAG system looks like. The LLM using NCP to access the data from different data sources. Let's think about a very interesting angle, or if you were the LLM, you are not a software engineer, you are the LLM. The user wants you to finish a task to retrieve the data from the data source. What kind of data what kind of data source you want to access to, and how would you want to access it? First, I think there are all kinds of different data sources. If you want to build a very powerful and a very useful RAG system, you need to use a different kind of data source like full text search, vector embedding. You want to need to use the time series data, relational data, document, graph, also maybe the block store like S3. A different kind of data. But in the old day, people are only focusing on the vector or the embedding. It is not true. If you want to build the tools like I demonstrate, it is not enough. So from the angle or from the perspective of LLM, what is the interface is the most friendly interface to the LLM? Okay? The answer is SQL. So I'm not saying this the right way, but on my own experience building so many different data agents, I think the SQL is still the best way to interacting with the data source through the LLM's perspective. So insight number one, SQL is the best bridge between LLM and the data source nowadays. Because let's think about that. For the human being, everyone knows SQL. If you're an engineer, you will definitely write select star from table, the predicate. And every LLM, basically today, tier 1 LLM will generate the correct SQL to access your database. And from the database part, the SQL is like a standard, and if you write the correct SQL to the database, that will always generate the correct answer and the correct data for you. And what's more important is all the process or the SQL can be reviewable by a human. So that will avoid a lot of the hallucination problem. Okay, the first insight, SQL is the best way. And the second important question, which is, when we talk about the memory system, we actually need to, the biggest difference from RAG and the memory, which is the memory can be evolved, can be updated. So I will give you the example here, also my own personal experience. When I asked my agent, can you pull my top 5 Salesforce opportunity this week and compare them to last month, something like that. So from the agent's perspective, it will trigger 2 memory systems. One is short-term memory. The short-term memory is very straightforward. It's just like the chat context in this session, plus the tool use, which is generating the SQL, query the database, and get the Salesforce event, and try to do some summary. And after the the summary or the output, and that will also trigger the long-term memory system, because according to this context, the LM will understand, hey, this user really cares about the revenue and the business, and maybe there's another fact like, oh, this user is actually live in the USA, so he may be interested in the revenue data, the revenue metrics in the US region. So that's how it works, and in this example. So let's deep dive into the technical detail, how we can use the unified SQL database to unify all the flow here. So before speaking the technical detail, there are different kinds of memory. The first kind of is external memory, I would say, which is the direction is session level, just like the demo I showed, the tool use example. For example, show me the Q2 revenue. It will generate the SQL to query the external database to get the result. Is what I call the external memory. And the second type, which is short-term memory. And for example, like I'm going to Tokyo, and in the early conversation, and in the same session, I talk to the LM, say, hey, can you give me some restaurant recommendation? And the LM will understand that in this context, I'm going to Tokyo. So it will generate the restaurant result based on the Tokyo. And for long-term memory, which is persistent, it is persistent in the database part. For example, in some kind of session, I talk to the LM, say, hey, I live in Beijing, but I moved to Shanghai, and now for the long-term memory, there will be the fact in the database, which called, hey, this user actually lives in Shanghai now. So 3 different kinds of memory. And if we want to build a self-evolving memory system, that's basically the architecture you should use. This diagram is copied from Mem0. It's an open source library building the memory system, but it's from a very high level. I'm not a big fan of Mem0, but I think this diagram is showing the overall architecture. If you want to build the memory system, you will end up with the similar architecture. So in the, for the agent memory system, there are two important components. One is the fact memory, fact database or entity database. The second part is confliction or conflict detection. That is the second important process. And another important component, which is the graph memory. So basically, today, in my own experience, that if you want to store something like memory, the graph is the best data structure you should use. Yeah. So three big parts. So the first part is the fact extractor or the fact database. So here is a SQL statement that creates that helps you to create the memory facts using SQL. So if you take a look at the code, you will find that it is a typical graph table definition. So you can see here is a subject, predicate, and the object, and with the object embedding for the similarity reasoning. And this is the table schema for the memory facts. And the next, which is the most important thing, is the fact extractor. In the normal best practice, you don't need to build a very complicated fact detector. You just offload this task to LLM. So in this part, you can consider LLM is a magic function that generate the whole bunch of conversation, and this prompt will help you generate the facts from your conversation and output it as a chiplet or the tuples like subject, predicate, and the object in the JSON format, in the structured format. So this is one of the most important components, which is a magic LLM function. So here is an example. When I send the input or the chat conversation, like I used to live in New York, but I just moved to San Francisco for the new job at ThinkCap, which is my company. And the LLM output will, through that magic prompt, will output the entities, which is the username, the city name, New York, and San Francisco, and ThinkCap, and also output the facts in the subject, predicate, and the object in the list. And the next step, which is very important in real world agent memory system, is entity normalization. And because when you treat LLM as a magic function to extract the entity, you will find that sometimes it will output the same entity with a different name. For example, in this case, TiDB is our product, TiDB. But sometimes people use PingCap TiDB or TiDB database, and it will not generate a stable output. But if you simply just put this entity into your graph, that will create a lot of redundant entity here. So in my practice, first we also use a database table to store all of this entity. But the tricks here is, TiDB also provides the vector index, create vector index for your data, so that you basically create the embedding for every entity. When you want to create a new entity, you will first doing the similarity search to get the top 3 similar entity, and send it to LLM to ask the LLM, hey, is this entity the same? Is the same thing here? And then you will solve the problems here. And Another good practice is always use the ID or the entity ID of the entity in your knowledge graph or memory graph. Do not use the the entity name in the knowledge graph. Yeah, there's a small tricks here. And the next, after the nominalization, and another most important topic about the memory is how to detect the confliction. For example, in the previous case, I moved to San Francisco, but maybe Beijing, and I recently moved to Shanghai. But there is already have a memory fact in the database, which is this user actually today is living in Beijing, but now he recently moved to Shanghai, and this component will do the very interesting way to find the potential conflicting facts. The first, if you search the system's username and the predicate, which is living, and get the existing fact from the database, and the step number 2, still using the magic LLM prompt function to put into existing fact into the prompt, and also the new fact, which is the fact in the conversation, and ask at the LLM. The first question is, do this fact conflict? Second, if yes, which one should be kept? The third, should the old fact be marked as invalid? So basically, you also the similar trick here is offload the complicated job to the LLM, and the LLM will answer, yeah, there is a conflict, keep the new fact, and mark the old fact as invalid. So, and then the next step, which is the update the database. Yeah, all consolidated or unified with a simple, elegant SQL query here. Okay, the next topic about the memory, which is the memory retrieval. So normally we do this on the graph database or different kind of Elasticsearch, Neo4j. But like I said, from the LLM's perspective, LLM wants to query data in the unified database or data store, and that's the SQL is still the best approach we have to assess the data. So even for the graph-like data structure, using SQL is still good, practical enough to assess the data. So here is an example for, if this example shows that the user 123 and get all the fact related to this user, and you can use this information as the prompt for as the context for the agent. This is the one-hop subgraph using SQL. And here is a more complicated example for, it's a two-hop pass in one query. It is quite useful for some, the reasoning or reasoning chain in the building some, complicated agent. Okay, so the takeaway here is, first, memory is not RAG, and the second thing is, SQL, just like I said, is still the best thing you have, and it is all you need. Basically, if you want to build some complicated workflow or complicated agent, you don't want to use a lot of different approach to feed the data to the LLM. Just use SQL. And of course, just like I said, vector database is not just enough. You want to maybe consolidate different kind of data source together. And quick question here, what about the performance? Now, my own experience teach me, the biggest performance bottleneck is not the database or the data retrieval. It's actually the LLM itself. So you don't need to worry about the performance, the latency anymore. And the second is, what about the scalability? Yes, that's something you should consider, because sometimes you don't want to delete the data anymore. In the future, every data will be somehow useful, so that as a database company, I always get the feedbacks from my customer. Hey, can I put like 1 billion of text chunk into your database to build a knowledge base or something like that? So I think in the future, the scalability in the for building the AI agentic memory system will be a big bottlenecks here. So yeah. And the third thing is, to me, in the future, like the vector index will be the must-have feature for every general purpose databases. Postgres have vector index, MySQL have the vector index, Oracle has the vector index, TidyB also have the vector index. Every database will have this as a built-in feature. You don't need to use another vector database anymore, because that is a must-have feature. Because that unlocks the software reasoning to do something like the similarity or semantic search on the database part. And yeah, the short-term action deserves a long-term memory by reflection. That's very straightforward. If you want to build the memory system, you will need to always have the process, like I mentioned in the slides, turn the short-term action and short-term memory, short-term chat facts into the long-term memory in your database. So the last but not the least, that's the key. If you don't know what to do, just use LLM as a magic function. For example, how to detect the confliction, how to extract the entities, how to extract the facts. No worry, just use LLM. Okay, that's a little bit different from in the traditional way of building programming. So yeah, I believe the LLM Lord. Due to the time, I don't have the demo, but just like I said, we have a very ambitious goal. And at TidyB, we want to build a unified layer for different kind of data for AI. So yeah, like graph, document, structured data vector, full text search, all in one platform with a LLM-friendly SQL interface. So that's our vision, and they're actually widely used in the AI community. DeFi is using TidyB as their underlying data store, and a lot of companies actually using that. So thank you. That's basically all my sharing. Yeah, just keep it slow.